Hello, hello. Thanks for this very nice introduction. So I'm very glad to be here today. And yeah, I'm going to talk to you about ICIJ and how we use technology and different data sources to do our work. Well, first small introduction. You probably don't know me, and I think it's better that way. So I'm Chief of Technology at ICIJ, and I've been working with leaks since 15 years, in fact. I started many years ago with WikiLeaks and other similar organizations, and since then I've been working on global investigation that involve a lot of journalists and a lot of technology, because this is probably what all those investigations have in common. So I will give you my contact at the end again, but if you want to reach out after this conference, don't hesitate to send me an email. I'm on every social network. You can even contact me on TikTok if you want. And I'm happy to hear your stories if you have any, or if you want to share any documents with us. So let's start with the ICIJ. I don't know how many people in that room hear about the Panama Papers. Can you raise your hand, maybe, the Panama Papers? Not bad. The Uber Files, more confidential, but still important. And ICIJ. Did you hear about ICIJ? Well, yeah, just a few of you. So this is because we work in the shadow, and most of the time you hear about Le Monde, the New York Times, the Washington Post, our media partners, but you don't really know about the organization that run those kind of investigations. So yeah, we are the ICIJ. It's a pretty old organization that started to shift to global investigation in 2014. And basically, we are a group of we are an organization made of three groups. The first one, the staff, like me. Second one, the members. And third one, the partners. So it's a bit difficult to understand. The first one, so as I said, the staff, it's about 40 people, a bit more now. We are across 4 continents. We mix knowledge between journalism, data analysis, coding, UX design, IT support, and basically our role is to coordinate those big investigations. But ICIJ started in, I don't know, I don't remember the date, 1988, I think? No, yeah, probably. But anyway, it was at first a group of members that basically exchange tips, knowledge, and it's very funny because the very first workshop, it was 25 years ago, they all met to learn how to use PGP. And so this group of journalists, they are all, very famous investigative journalists in their own country. In France, we have, Fabrice Arfi, we have... I don't remember. But anyway, we have many famous investigative journalists in many countries. And yeah, and they, at the beginning, just exchanged tips, but they were not really working together. And so because ICIJ wanted to use that member group, they created partnership. And so those partners are really working with us during investigation. Some of them are members of ICIJ, some are not. For instance, in France, we work with Le Monde, with Radio France, with Cash Investigation, and most of them are not members of ICIJ. They just work with us during investigation, and we consider them as partners. So as you can imagine, it's a pretty big role to coordinate this work between that many people and that many organizations, and this is what we do at ICIJ. This is really our specialty, and I think we kind of give everyone the playbook to know how to coordinate this kind of investigation, because before ICIJ there was some great effort to work together with different news organizations, but really ICIJ made it professional. So today I'm going to talk to you about 5 ICIJ investigations using AI. I'm going to talk to you about this investigation very briefly. If you want to know more about them, you can just go on our website and you will see all our stories. And I will explain to you how we use AI along the years and other technology to enable investigative effort. So the first one is going to be the Implant File, 2018. It was a global investigation on medical devices. Medical devices can be many things, like a pacemaker, for instance. But we realized that it was a very unregulated sector, and there was a lot of problems with those devices around the world. But you know, when you don't have any numbers, when you don't have data, you cannot really give a diagnosis of a problem. It's very hard to know, if there is truly a problem with medical devices or the regulation. So we tried to work on several data sources. One of the most important one came from the FDA in the US. And so basically we got what they call adverse events, which basically are events where a device is suspected to have caused serious injuries or even death with the patient. And the problem with those adverse events was the fact that they were all redacted. There was just text. So, very hard to extract numbers and statistics when you just have text. Also, they did what we called underreporting, meaning that instead of saying someone was dead, they were saying something like the patient expired or something, not very clear, that for human was obvious, but for a machine was much harder to analyze. Also, all the data we had in this report were just, as I said, plain text with absolutely zero structured data, so zero spreadsheets, zero columns. It was very hard to analyze. So that was the first time that ICIJ used machine learning to try to identify which reports were talking about someone dead and which one was not. And also we wanted to know if there are some sort of discrimination or, a population that was more victim of those problems. So we try also to extract genders from those reports. And well, we didn't do ethnicity because most of the time it was not in the report, but that would have been an interesting aspect of the analysis. And so we listed a lot of terms that we knew was related to death. And we basically train our machine learning algorithm to identify the report, the death, and read the description for us. Thanks to this process, we managed to extract more than 2,000 cases where the patient died. So it was quite a success for a first attempt, but it was also very expensive. It was in 2018, so at the time, machine learning was good, but not as good as today. And it was also making a lot of mistakes. So, in fact, our reporters read all the cases that was flagged as, positive in this analysis, and they read them. So basically, we did machine learning, and then we had reporters to read the report to confirm the machine learning was right. So you might think, well, what the fuck? Why do you need machine learning if you read everything? Well, it was an experiment. So we had to verify the work from the machine learning because ICIJ has one secret recipe. It is the fact-checking. Everything we publish is fact-checked 3 or 4 times, which ensure that when we publish something, when we publish a number like this one, we are certain that this number is true. And the result is quite important because ICIJ is doing this kind of investigation since many years, but we never get sued by anyone. We got, of course, threats. We got threats every day, but nobody was able to sue ICIJ because all analyses we did were fact-checked and were backed by a team of reporters. A bit later, I think, almost the same years, we did the Mauritius leaks. So we got tons of documents from an offshore law company. We really like offshore law companies. And we had to coordinate the effort with our African partners to explore those documents. The problem at the time was the size of the team. We didn't have many partners in this project. It was something like 30 partners, so it's not a lot. Usually when we do investigation, it's more like 400 partners. And so we really needed to explore those documents in a very smart manner. We really needed to create a way for those journalists to quickly identify interesting documents. So we worked with Quartz. It's a news media outlet that is, I think, it closed. So it used to be great, but now they drastically reduced the staff along the years, and I think they don't exist anymore. But at the time, they worked with us to identify similar documents. So what are similar documents? It's a very interesting aspect of the research. When you have many documents, you really need to be able to classify them. So we try to classify them to narrow down the research. We created several technology like tax returns or business plans, and we train our models to identify those documents. So if a journalist wanted to get all the business plans from the leak, they were able to do it and do more research. It was a very interesting approach because for the first time, instead of using existing models and asking our own team to do it, we involved the partners and we asked them to help us to flag documents by categories. So we did what we called supervised learning. So many reporters helped to flag documents. We taught the model that a document was in a certain category, and then we were able to scale and to analyze all the documents automatically. As I said, this significantly accelerated the process of exploring the documents. And it was also the very first time that we used machine learning, not to create any sort of analysis, but mostly to speed up the research. So you might wonder what it looks like. So this is DataShare. This is our search engine for leaked documents. It's a technology we created many years ago that is open source, that you can use on your own computer. You can install it in a few clicks, especially if you're on Linux. It's super easy. But you can also use it on your server. ICIJ use it on their server to explore millions, terabytes of leaked documents. And well, we started to develop that in 2015 to basically distribute the work of reading the documents and putting them into an index. And so here we created this very simple feature that is called tags that you have on the left, where you can see that we created clusters of documents. So we classified some document by clusters. So as I said, the journalists were able to quickly filter out documents falling into a certain category. Then it got bigger. The year after that, we got another leak. This investigation was called the Luanda leaks. It was basically a lot of records, a lot of files related to Isabel dos Santos, which is the daughter of the former president of Angola. And very quickly we realized that she was using her power and her network to get money out of Angola, even public fund. But as I said, again, there was a lot of documents. And the problem, it's not a problem for Angolan people, but it's a problem for American journalists or French journalists. The documents were in Portuguese. So how do you coordinate an investigation that involves hundreds of journalists if they don't speak Portuguese? So you might say, well, easy, let's use Google Translate, right? In fact, we can't do that. Well, first, we don't want Google to have our documents. And second, we are legally not allowed to do that because it will be like sharing our documents with Google. And if we are protected because we are journalists, Google is not. So Google could be, I don't know, sued by Isabel dos Santos because at a point they processed our document on their servers. So yeah, preserving the secrecy of the investigation while allowing many journalists to explore it was very important. So we decided to use offline translation. At the time, we use an open source technology called Apertium. It's very famous. It's very fast, but it's not very good at translating from Portuguese to English. In fact, they have no models to translate from Portuguese to English. So we did something very dirty. We translated from Portuguese to Spanish and then to Spanish, from Spanish to English. And so, as you can imagine, the translation was very, very bad. Honestly, I'm not proud of it. But it was still good because with this translation and with data share, our reporters were able to search into, hundreds of documents. So even if they were typing words in English or in Portuguese, whatever, they were able to find documents. And then, even if the translation was not good, they were able to either use a Portuguese speaker to help them, or they could, just try to understand it correctly. Since 2020, we really improved this technology we created to translate a lot of documents. We are now using Argos Translate, which is much more efficient, much more good at translating from Portuguese to English. So now the translations are great, but they are also much smaller. So it takes forever to translate that many documents. So that means that we are still able to use Apertium to translate those documents if we need to be fast. If we have millions of documents, we will probably need Apertium. But if we have less document, and I will talk about it later, we can use Argos, which will provide a great translation. As you can see, and you will see a lot of links in the bottom of the screen, we published the technology we use to translate all those documents, because as you can imagine, we cannot run that on one single server. We had to distribute it. And so we created a technology that was able to distribute the computation between different servers using a bus to share the work. And it was extracting the text from an Elasticsearch. So we called it Elasticsearch Translator. It's open source like everything we do, and you can find it on our GitHub like many other tools. Then the year after that started the biggest investigation in journalism history. Not because of the impact was huge, but in terms of the number of people involved in this investigation. We got more than 400 journalists working with us during that investigation. We started to get the leak in 2020 during the confinement, during the lockdown. But the investigation itself lasted for almost 2 years. And so we had a lot of documents, almost 12 millions of documents that came from 14 different offshore providers. So an offshore service provider is basically a company that helps you to set up an offshore company or an offshore entity. There are many of them. And usually they have for customers very rich people that don't want to pay taxes. So 14 of them, great, a lot of stories to tell. Problem, all those files were pretty complex to read. Most of them were in English, that's easy, but a lot of them were just ink of paper, so either scans, handwritten text, or just very long report with a lot of information. So we needed to be able again to identify some very specific type of documents, and also to extract structured data from those documents. So for the first step, again, we use data share to analyze the documents and to search through them. And we use machine learning to identify documents by categories, just like we did for the Mauritius leaks, but more than 10 times bigger. The problem with this machine learning operation was the cost. When you use machine learning algorithm, you have to store vectors to speed up the process. And when we try to store the vectors of all those documents, it was massive. A lot of data to store, and at the end, combining the storage and the computation, it cost ICIJ $50,000 just to do this, document classification. So not ideal. That's something I will do every day, but that was worth a try because it allowed us to search through the document faster. As I said, we also wanted to extract structured data. It's important to understand that when you have such big leak, a lot of them are PDF, emails, Word documents. Some of them are spreadsheets or databases, but it's a very tiny portion. And the problem with this kind of leaks is the fact that there is so much personal data in it that you cannot just release it with everyone. Because if you do so, people will be in danger. We have in this leak, like the ID card of Shakira. We have personal emails, poem, love letter, this kind of stuff. So very personal. So you don't want to publish that on internet because people will be in real danger and there will be a huge confidentiality issue. But there is a lot of stories that we cannot tell because we are still a small organization, and even if we involve a lot of journalists, at the end of the publication, the work is kind of done. You don't go back so often on the leak. So we really wanted to extract a list of all the structured data, all the companies present in this leak, to publish some sort of offshore registry. So, offshore jurisdiction, they don't have a public registry of companies. That's why they are used, for as tax haven. So we had a lot of companies in this leak. So we wanted to extract those companies and publish them in what we call the offshore leaks database. You have the link again here. And so anyone, you or any researcher out there can use our data to do their own research. And it works. Very often we got requests from journalists because they found an interesting name that was not interesting last year, but it is interesting now. Just let's imagine all the new deputies that might be in our database that were not very famous last year, but that might be famous next week. And so those journalists contacted us and they said, well, I found some interesting result about that person. Can you give me the documents or give me access to the Pandora Papers? And so this process works very well. ICIJ is committed to give access to as many journalists as possible to those kind of documents. And so because we created this corporate registry, where we really are able to recreate new collaboration on the basis of this database. So to do so, sorry, I skipped a little bit that part. We extracted structured document using machine learning again. So basically we trained our models to recognize the name of the company, the name of the officer, so the person that have a role in the company, and this kind of stuff like the address. And at the end, we were able to publish all that data that was extracted automatically on this website. As I said before, our secret sauce is fact-checking. We get a lot of analysis, a lot of documents, but when we want to publish, we need to check that it's true. And so because this process is very hard, very long, we decided to create a platform to make it a bit more playful. We kind of gamify the process of fact-checking data. So we created an open source platform. It's very simple. It's based on Django. You can publish it, read it on your server, and it basically offers you a way to upload a spreadsheet and upload a list of value. So you say, for instance, I don't know, I want to identify countries in this spreadsheet, and then the reporters are able to say if the value you extracted using machine learning is correct or not. It's just that's simple, just verifying data. And because we built this platform, Prophecies, the reporters in our team managed to verify all the records we extracted using machine learning pretty quickly. So it was pretty fun to do for us. It's funny to do some sort of Tinder-like, but for fact-checking. But it was also very fun for them because they have this nice interface they could use on their phone. And, you know, I remember one of our data journalists was working by the pool. She was, you know, just swiping on her phone to verify the machine learning result. We are still using Prophecies for many other projects, but we really created this nice and friendly interface for the Pandora Papers. Last year, we released another investigation into offshore activities, but this time in Europe, in Cyprus. It was called the Cyprus Confidential, and we got our hand on a lot of documents that were basically showing that Russia was using Cyprus as a gateway to Europe. So they were either buying European passport, or they were, you know, setting up companies or whatever you need in Cyprus to have access to funds directly in Europe. Problem again, a lot of documents were in Greek and Russian, so we needed to translate them. The problem here was the fact that the way the documents were formatted, it was very hard to detect the language of the documents. So we had this problem, you know. We tried to OCR a document to turn an image into text, but to do so, we need to know the language of the documents. But to know the language of the document, you need to extract the text, and you know it's almost impossible. So it's you know you can have very efficient OCR technology like the one we use, but in that case, it was just not working. So we created another open source technology that we call PLD, for PDF Language Detector, that was able to OCR the documents in different languages. We just asked for Russian, Greek, and English. And then it used the confidence level to assert what is the language of the documents. And so, thanks to this process, at the end, we were able to identify the language of every document correctly. So we were able to OCR it correctly. Search results are much better when you recognize Cyrillic as Cyrillic. And we were able to translate them, obviously, using the technology I mentioned before. So again, machine learning helped us to speed up a process that could have been done by hand, but because we had so many documents, we were able to do it in a much more realistic time frame. As I said, we have a lot of open source technology. I'm a strong believer of open source. It started many years ago, and I still think that it's the best thing that happened to the world since computer exists. And ICIJ really want to follow that philosophy and publish as much as possible the source code of what they do. So as I said, we created this data share search engine that you can find on this address that you can download on your computer. So sometimes it works, sometimes it doesn't. Be patient, please. It's not that easy to set up this kind of search engine on a computer. Keep in mind that when we use it, usually it's on dozens of servers. So it's not easy to fit that kind of computational power on a laptop. We follow a philosophy that we call extreme scalability, meaning that we build this software, we designed it so it can run on small laptops with small memory, but it can also run on hundreds of servers. And so when we get a leak like the Pandora Papers, we already have the tools to analyze all the documents. But if you do have a leak, you know, there are so many now. Just spend, I don't know, 30 minutes on the dark web and you will probably find something to download on your computer. You can use DataShare to help you to navigate the documents. Our primary focus is unstructured documents. So they are PDF, words, images, so things you know that are not so easy to read for most computers, but that DataShare is able to read pretty quickly and pretty efficiently. And we support something like, I don't know, 2,000 different file formats. So when you have a leak and you have a jumble of different file formats, DataShare is able to read them. So it's at the very center of what we do. As I said, it's performing OCR using open source technology like Tesseract. It uses name entity extraction using open source models. So you are able to identify name of people, organization, and places. And it basically allows you to search through your document with a bunch of filters. As I said before, we use ES Translator to translate the documents. So this is also an open source technology that you can run on your computer. You have to be a bit familiar with command line to use it. But in just a few clicks, you will be able to run translation on your Elasticsearch index, and it will just work. So I guess it's a pretty big plus for us. So what's next? There are so many leaks out there, so many different kind of data that we still struggle to analyze. So what we really want to do in the future is to make DataShare a platform that you will use not only to read your document, but also to perform your own analysis. So you don't have to care about, can you read this PDF? Can you read this image? Can you read this Word document? Can you read this huge mailbox you have access to? You won't have to care about that because DataShare will extract everything correctly for you, as it already does. But then DataShare will offer you an API and a sandbox so you can run your own analysis over the document. So let's say you want to identify different clusters in your leak. DataShare will really offer you an environment where you can run your own analysis. If you want to use Java, I don't think many people will use Java, but anyway, if you want to use Java, you will be able to do it. If you want to use Python, JavaScript, whatever, DataShare will offer a space to do that. We also want to create some sort of service around DataShare, but it's not our priority right now. Thank you very much, and if you have any question, I'm all here. And I forgot to say, we are an NGO, so we are donor-based. So if you want to support our work, I encourage you to go to that link.
So, do we have some questions? Yep.
I was wondering, how do you get the data you do for your investigations? Do people send it to you? And if so, do they use specific tools? Is DataShare usable to share some data with you? And yeah.
Thank you. So yeah, it's a big topic. I spend a lot of my time meeting with sources and traveling to get an hard drive and just go back home and basically put it into DataShare. That's mostly how we start an investigation. But as I said, ICIJ is also a network of members. So there are, journalists around the world that have their own documents. So very often they come to ICIJ and say, hey, I have 2 million documents. I don't have the servers or the technical skills to analyze them. They just hand it over to ICIJ, and that's how an investigation starts. Of course, not every leak leads to an investigation. This is why we have so many reporters at ICIJ. But I think the best way yet to start an investigation is probably to share documents with us. We do some investigations that are not based on leak, like the Migrant Files I mentioned before. It was not based on leak. It was based on public data and data we scrapped from a public website. But yeah, most of the time, if you have a leak, it's probably the best way to work with us. We work with only news organization. That's one of the reasons why we are protected. But our sources can be anyone, like insiders, hackers, whatever. And I think you asked a question about how we review the data or what's the process. But basically, it's a very manual work. When you have so many reporters, you are able to distribute the effort of exploring the documents. But that's it. There is not really any magic formula to review the documents. Just have to go one by one and read them all.
Hello, thank you for your presentation and for the work of ICIJ. It's very important for our society, so please continue.
Thank you.
What I want to ask to you, if the findings that the journalists are finding. I wonder if some people that are targeted by these leaks, if they want to target you and steal the information that you have found, and how you do that. I imagine as every company you protect as much as you can.
So every investigation starts with the threat modeling. We have to know who are our enemies, what resources they have, and in most cases, all the one I mentioned, they don't have that much resources because our enemy is not the NSA yet. But yeah, at the beginning of every investigation, we try to assess what's going to be the risk and what security measure we're going to take. I didn't really talk about it, but in fact, we are pretty strong on that point. I mean, we do the best we can. And every time we publish something regarding one of those actors, we got DDoS attack, we got intrusion attempt. So we are very careful. It's almost never possible to know where the attack comes from. So most of the time we just guess. But very often it's the same kind of actors, like, Russia.
Hello. Have you a common language structure to speak between journalists?
A bit louder, please.
Yes, sorry. Have you a common language structure, like sticks, for example, in cybersecurity, to exchange between journalists, or is just the data share model that is used by everyone, and that's become de facto this language structure?
So I'm not sure to get it, but I'm going to try to answer anyway. Tell me if I'm wrong. So all the models we use are open source and published with DataShare, and the one we use to analyze the document are in fact coming from other organizations. So we don't have our own models. But as you can imagine, when we have so many documents, we can train models with a very unique data set. So that's something we also try to do. Currently, we are working with the Oslo Met University to build a model that is able to detect passport and basically extract the name of the person, the country, the date of birth, the photo. And when we have a leak, because thanks to this model, we are able to quickly recognize passport. The problem is that we cannot really publish this model that is trained on confidential data because, there are ways to know if which document have been used to train the models. You can retrieve some of the information analyzing the model. So it's not trivial, but it's possible. And so it's not a risk we are willing to take yet. And so that's why this kind of model are still not open source. But the technology to train the model is open source. And so if someone has their own data set, they can train the model themselves using our technology.
Yeah, thanks. You mentioned you had a few dozen people as staff, a few hundred as members. Do you have a ratio of technical people in both of those groups? Because it seems like a huge amount of work.
So in the member network, it's close to zero technical people. It's just journalists. And some of them are not the same generation than me. They don't really use technology to do their work, so they don't have much interest. But at ICIJ, the organization, I think it's a third of the organization that is, no, even half of the organization that is technical staff, meaning developers, data analysts, data journalists, IT people. So yeah, I think it's pretty unique to have a news organization where such a big part of the staff is technical.
Country can see you like a stress.
A bit louder, please.
Country can see you like a stress. Secret agency is a partner or an enemy for you?
So the question is, countries can be our enemies, and surveillance agencies are either a threat or a partner for us. Am I correct? So I would say an enemy, without any doubt. We never share anything with governments. We don't share anything with intelligence agencies. We know that some intelligence agencies use our open source technologies because they told us, but we don't want to work with them. That would create a very dangerous precedent for the work of the journalists that work with us. And and we will continue that way. One of the reasons why we publish the Offshore Leaks database is also because we don't want to work directly with government entities. But we know that when we publish the Offshore Leaks database, the tax authorities, for instance, took the data and ran their own research. In France, just in France, it's estimated that they managed to get 400 million back from the taxpayer just using our data, just using the data we published. In the world, we estimate it's about 1.5 billion and 2 billion, but we don't really know because they don't always communicate. Like the US, they don't say how much is based using our data. But we will continue to publish data as much as we can because we know that it can have an impact even after the work of the journalist is done.
I was wondering which kind of infrastructure are you using? Is this on-premise or maybe you do both with some cloud provider? And also another question related to something you said earlier. You said that you have multiple sources, and I wanted to know if you assess your sources and if you have a way to ensure that nobody is trying to poison your data.
Right. So we have cloud infrastructure and other infrastructure that are in secret locations. Our cloud infrastructure is Amazon, mostly because it's easiest, not the cheapest, but easiest option we have. And also because it allows us to scale. So when I woke up in the morning, if I need to analyze 10 million documents, I can do it in a day. But we also have other infrastructure for more sensitive documents. Everything is encrypted, obviously. But yeah, that's probably one of our biggest weakness is the fact that we have to use a server provider, either it's AWS or Google Cloud or whatever. We have to trust someone else. We know that there are some friendly organizations like Flokinet, for instance, in Iceland, that offer great protection for journalists. And we try to use this kind of organization as much as possible, but when we do so, we don't make it public because we don't want to, attract people to the servers. And to answer your second question, yes, some of the source we got might have an agenda, an hidden agenda. It's always an issue, and every time we have to assess it. But the question is, what's the public interest when we receive data, for instance, from hackers, ransomware organization? They benefit from us if we work on the document they share because that allows them to do their business because that creates some sort of pressure on their victims. But if the data is important for the public interest, we will still investigate it and we will still try to find interesting stories for our readers. Sometimes we got leaks from different sources and we decide not to use it. Of course, we do some research first, but we decide not to use it because we realize that the public interest is too little or not worth the risk. But in situations where we know that there are potential interferences, that's where the fact-checking part is very important. Because, very often people think that it's because we got an email of someone saying they want to create an offshore company that we're going to write it in the paper. It's not how it works. We got an email with someone that wants to do that, then we investigate, then we verify this information, and then we are able to publish it. For instance, if you take Shakira or Elton John or any famous person in the leak, of course we find them much faster because their names are known. But once we got this kind of information for this kind of person, we really need to run the kind of verification that we will do for any other kind of stories. So we have to to verify that the company exists. We have to ask the company that set it up if they did it or not. And there are many, many laborious steps before publishing the story.
Do we have other questions? Nope. Well, feel free to send all the data leaks to ICIJ.
Yes, please.
Thank you very much, Pierre.